Biomass energy refers to energy from products derived from living organisms. Just like fossil fuels, biomass is formed by the sun, which through a process called photosynthesis converts carbon dioxide and water into organic matter. However, unlike the fossil fuel that takes millions of years, biomass can be produced in a very short period of time. In this module, we would like to talk about how the biomass is formed, what is the process of photosynthesis, and eventually how we can acquire power through biomass. Biomass includes anything non-fossil fuel, organic matter, anything organic. Could be foodstuff, could be husks, peanuts, shells, and of the trees. It could be different trees that we cultivate as energy crops, and even the municipal waste and yard waste can be considered biomass. Tires and sewage sludges contain a lot of biomass, but also contain some carcinogenic material, and therefore cannot be used as a biomass. So some people consider those to be biomass, and some people consider to be, not biomass, because of the carcinogenics which are included in those. Photosynthesis, the word is made of the word photos, which means light, and synthesis means to build. It is a building of carbohydrate through light. What it requires carbon dioxide, water vapor, which is inside the atmosphere, in the oceans, in presence of the sunlight. Then the carbon is fixed and turned from the inorganic matter to organic matter in the forms of carbohydrate. To do that, we need the sunlight of certain frequency to capture the light. Red is the best frequency to have the sunlight. As the move away from the red toward the lower and higher frequency, the efficiency of production of this carbohydrate dramatically reduces. Photosynthesis can happen in aerobic, that means in presence of the air, and anaerobic, which is in absence of the air. It can also happen in the air and in the water. The reverse of photosynthesis is called respiration. In this case, we burn carbohydrate and the oxygen and get back the carbon dioxide and water. In the process, some energy is produced. That's the energy, for example, we use for our metabolic activities. The difference between the photosynthesis and respiration is, however, that in photosynthesis you need the sunlight, but in respiration it can happen even in the total darkness. A food chain is a path through which animals find their food. The simple food chain starts from the plants, that they make their own food, they don't rely on anything else, they call them producer, and passes on to other animals, which we call them consumers, through 1 to 3 or more nutritional stages, called the trophic level. So, primary consumers are the herbivores. Those are the vegetarians. They feed only on the primary form of the food, the simple food. And then the second consumers, like the carnivores or the eat-meater, that they rely on the meat which is produced from the primary forms of the simple food. For example, we eat the cow meat, and the cow is fed on the grass, so that would be a secondary consumer. It should be noted that although nutrients continuously undergo cyclic processes, energy does not. We know from the laws of thermodynamics we discussed before, in order some work to happen, something happens, the energy always degrades from the more concentrated form to more diffuse form. And this is what happens in the food chain too, in the process of photosynthesis. So energy is being more diffuse, so that cannot be recycled. However, the nutrients in the food chain are always go back to and recycled over and over again. There's something called the rule of 10, which basically says that when we move from one energy level to the energy level below it, 90% of the energy is lost. Only 10% is going to pass on to the next level. For example, if you use the solar energy, when you use 1,000 calories of solar energy, the 1,000 calories of solar energy will turn into only 100 calories of the plant energy. 900 calories of that, or 9%, is wasted to the heat to the atmosphere. Now, if we are a vegetarian, then and we consume 100 calories of the plant energy, only 10 calories of that would be used by the humans in making the activities that human being needs. That is metabolic activities and other uses for the energy. So in this case, only 10 calories out of 1,000 calories of the sun is useful to us. If you are a carnivore and we are a meat eater, then thousands of calories of the solar energy will turn into 100 calories of the plant energy. Off of that, only 10 calories goes, to the meat, and then 1 calories of that comes, being consumed to us. In every trophic level, 90% of the energy is wasted. From this diagram, you can see that the vegetarians are about 10 times more efficient in preserving the energy than the meat eaters. This is what many cultures, for example Indians, they believe, that they are a vegetarian, I believe, is because this is a very sensitive way to feed more people with a less amount of food. We can produce power from biomass in different ways. First of all, let's talk about the different biomass. There can be several types of biomass. We can have energy crops. Those are the crops which are cultivated specifically for use for drive energy later on in the form of ethanol and other liquid fuel. Also, the municipal waste is a form of the biomass. Majority of this is the animal and human waste, that will be a biomass, and also the bacteria. These are the three forms of the biomass that we use to produce power. Wood can be burned directly in fireplaces. Some countries like India, even they use the animal dung for heating and cooling. But most of the countries, biomass is incinerated, is burnt in a especially designed furnaces, or converted into the liquid fuel before burned directly as a source of heat. They can be used in the automobiles or in the power plant to produce other forms of energy such as steam or electricity. The three major sources of biofuels in the US is the corn, to use it for the corn ethanol. In the Brazil they use the sugar cane, and much of Europe they use Miscanthus giganteus, as these three diagrams shows. The left is the corn, the middle one is a sugar cane, and the one in the right is a very tall trees that can be seen here, and those called Miscanthus giganteus. Energy crops can be divided into the first generation energy crops. This could be either the bioethanol or biodiesel. Anything which has a lot of sugar in it can be used very simply to turn into the bioethanol in the process called fermentation, which some kind of yeast converts, this material to alcohol, as we do in the production of alcoholic beverages like wine or beer. Same process, it can happen here and produce alcohol. So anything with a lot of sugar, like corn in the United States, sugarcane in Brazil, are suitable for producing the first generation bioethanol. Some other oily substances, the seeds, soybeans, sunflower, maize, etc., they can be also used to produce biodiesels. The second generation energy crops are cellulosic plants. These are cultivated in any climate, so they're very, very convenient. They require much less water than the first generation plants, and we need less fertilizer. They're rich in the energy, and most of the time they don't have any food values. But the problem with this, they are hardest to break down to smaller molecules and ferment them. So now we move more from the first generation to the second generation with the new technologies, and so that makes the biofuel a lot more convenient and not be fighting the food resources. Energy crops can be short rotation crops that can be cultivated in the cold and the warm weather every few months. The grasses, the plants in the water like seaweed and algae, aquatic plants, herbaceous plants, those are the sugarcane, corn, bamboo, sorghum, and the oil plants such as soybeans, cotton, sunflowers. These are all considered to be energy crops. This diagram shows the biomass, how much energy can be derived from it, the heating value of them, and that one is given. For example, you can see from this diagram, sugarcane, most of this stuff are having roughly the same amount of heating value per kilogram. The only thing I put here is a methane, methanol, and ethanol, and these are methane has a higher the heating value, and this is a fossil fuel. Methanol and ethanol usually found from the biomass, so they have roughly the same heating value as the other biomass like waste, newspaper, sugarcane, etc. We can produce power by using many technologies. The main one is incineration. In the incineration, you burn something in the air. It can be in the burning in the oven, in the boiler. It can be burned at very high temperatures, like a plasma heating, or it can be mixed with the coal or other fossil fuels in the co-firing. So it's a mixture of the coal and the biomass. When you burn those are co-firing. All of them are using the incineration. That's burning. In addition to burning, we can have thermochemical conversion and biochemical conversion. Thermochemical conversion could be divided into pyrolysis. The pyrolysis, no oxygen is used, no chemical reaction, combustion is involved, and you just heat up the product to a very high temperature in absence of oxygen and air, and to make it into a gasification, to a gases, and then you can add, if you want to, some oxygen or air during this process to convert it into other fuels like the gases, like syngases that can be burnt later or turned into a liquid, and like ethanol or bioethanol. So pyrolysis means no oxygen. If you add some oxygen to it, it's a process of gasification. There are other processes like a Fischer-Tropsch, which was developed by Germans during the Second World War, that they found they could convert coal into the synthetic fuel and liquid to run their basically military machines. In addition to thermochemical conversion, we can use biochemical conversion, which is basically producing ethanol by fermenting through the microorganisms such as enzymes and fungi, bacteria, that they basically accelerate the conversion by breaking down the long-term cellulose and starch into sugar that is then fermented into the liquid hydrocarbon.